Okay, hello everyone. Today we're going to be doing another Olympiad geometry question. So let's get into it. Okay, so I'm just going to zoom in a bit more. So the diagram shows a semicircle with radius r inside a right angled triangle. The shorter edges, tangents. Okay, so this is key. So let's just draw these lines. We know that these are both right angles. And before we finish reading off the question, another bit of information is that, okay, so this is a four-sided shape and three of the sides are right angles. So let's just draw a fourth one here. It might not help us, but it's just good to draw these pieces of information on, since you never know, they might help you. The diameter of the semicircle lies on the hypotenuse of the triangle. Okay, and we need to prove that 1 over r equals 1 over a plus 1 over b. Okay, so this is a square, so let's just label these four lengths as all being r. And okay, so what we could do is we could work out the area of the square and then the area of this triangle over here, the left one, and the left small right angle triangle as well, and then set all that equivalent to being the same as the large right angle triangle, but that's very long-winded. So maybe a more smart method of doing this is just drawing a line through this. So this line looks like it bisects the hypotenuse perpendicularly, but we can't make that assumption. So, but what we can do is we can set three different area terms together, and hopefully we can find a link between them. So the large right angle triangle has the area of half a plus b, which equals the two smaller triangles inside here. So this smaller one, the smaller left triangle, basically the area of this smaller left triangle equals, I'm just trying to find out how to express this best. So, okay, let's draw this left one over here. Okay, that is far too steep. If we just draw that here, we don't know if this is a right angle, so I'm not going to label that. But this is R and this is B. So that left triangle can be expressed as R times B divided by 2, so half RB. And if we do a similar procedure with the right triangle, it's basically the same thing except with A. So plus a half A times R. I'm just going to write this as this. It's a bit cleaner. Okay, so now let's just multiply all these terms by 2 and see what we get. So AB equals RB plus RA. And we need to prove that 1 over R plus 1 over A, 1 over R equals 1 over A plus 1 over B. So let's just rearrange for R, I guess. So R equals, you can just write this on like this. And therefore we'll divide both sides by A plus B. So we get this following equation. So R equals A times B divided by A plus B. So, okay, now this can be written as AB divided by A plus B. So let's just break up this fraction into two separate components. And so A divided by A plus B plus B divided by A plus B. And we have the R term over here. So now, if we just continue working with this, hopefully we get a situation where 1 over R equals 1 over A plus 1 over B. So let's just, maybe let's start by reciprocating all the terms. So 1 over R equals A plus B over A plus B over B. So now if we divide, actually having done that, that may not necessarily be true. I'm not sure if it's true, at least. Okay, so let's just go back to our initial. We need to, any other links which we have between A, R, and B. I'm not sure that we do, but okay, so maybe instead of doing that, if we multiply both sides by A plus B, then we get this equation over here. So this might help us, I'm not sure. But we have this. And now if we divide everything by half, not a half. Okay, so if we divide everything by R, I guess, we get A plus B equals AB over R. And now we might be making some progress. So now if we divide everything by A, we'll get 1, just regular 1, sorry, nothing else, plus B over A, which equals B over R. And now if we divide everything by B, then we're starting to eliminate all these terms from the numerator. We get 1 over B plus 1 over A equals 1 over R, which is our solution. Okay, so this method was much easier than any other methods which you could have used. Before I tried this method, I tried a very long-winded method, which was calculating the area of this square, and then the area of this right-angled triangle, and then the area of this right-angled triangle. And these two right-angled triangles are similar. So if you did that, you would have found that it's a very, very long-winded method. I did eventually get the answer, but then I looked up the answers and this method was much cleaner. So yeah, I hope you enjoyed something from this video and hope you learned something. I guess the key learnings from this are that normally these Olympiad questions don't require really, really, really long solutions. And they normally require the right approach right from the beginning. So in this question, the key bit was probably identifying these two large triangles and how we could split up the right angle triangle into these two and setting up equations for the area of both of these. So yeah, I thank you for listening and I hope to see you next time. Bye.